Here's a video on fundamental polynomial connections. So before you begin, you'll notice that a lot of questions ask you to using the factor theorem or refer to the factor theorem. So here is first a definition of the factor theorem. A factor theorem is if f of a is equal to 0, then x minus a is a factor of polynomial f of x. I know having like the theorem written out like this doesn't really make sense until it's applied to an actual example or a question. So here's an example just to help us understand the factor theorem. So we have here f of x is equal to x squared minus 5x plus 6. I know that based on the skills that you got from Algebra 2, that you can actually factor this without using the factor theorem. However, just for the sake of this example, we are going to use this polynomial to try to grasp an understanding of the factor theorem. So let's say we did not know how to factor this. Then based on this question, what we're going to do is you'll notice that if the f of x, if we plug in a, it should equal 0. Then it's a factor. So I'm going to go from the top. Let's say I use starting from choice A. First, we want to solve for a. So if x minus 1 is a possible factor, we're going to make it equal to 0 and solve for x. So you'll notice this x is 1. Then we're going to plug this 1 into a function. So it's f of 1 is equal to, and we're going to plug everything in. The moment we simplify this, if this is equal to 0, you'll notice up here, because right now we plugged in a, if it equals to 0, then it's a factor. So I'm going to solve this out. 1 minus 5 plus 6, negative 4 plus 6, positive 2. So you'll notice that it does not equal to 0, so x minus 1 is not a factor. I'm going to erase this, but since you're watching this as a video, you can always go back and rewind. So let me erase this and we're going to try option B. So same concept, we're going to first make, let's do a different color, forest green. We're going to first solve for x. So it would be x is equal to 2. This time we're going to substitute 2 into our function. And our goal is to get equals 0. So here, I plugged in 2. I'm going to simplify. And we got it. It equals 0. Since, according to the factor theorem, if you substitute a and the entire function equals 0, then x minus a, which right now for our question is x minus 2, is a factor of polynomial f of x. So now we know that that's a factor. Okay. So how does that even work, right? So I'm going to erase all these steps. Once again, you may rewind if you would like to see the steps again. How does it work? So if we got this function, I know that you know how to factor. So if I were to factor, it would be x minus 3 and x minus 2. Let me put the f of x in there. So if I were to just directly factor it, I get x minus 3 and x minus 2. You'll notice that if I put 2 in here, my entire function would equal to 0. And that's why before we factor, the fact that we substitute 2 into this function, that's why the entire equation is equal to 0. It's more clear because for this function, we're actually able to factor. But let's say we didn't know how to factor. So example, here's an example from the homework. This is question number 5. H of x is equal to x minus 1 is a factor of f of x is equal to x fifth plus 1. So now they're asking you, the two choices are true or false. So is this a factor of that? So this time, unlike our previous equation, we don't know how to factor this. So we're going to first solve for this x here. So we have x minus 1 equal to 0. Solve for x. X is equal to 1. Now if we get this number and substitute it in, if it equals to 0, then it's a factor. 1 to the 5th power is just 1. You'll notice it equals to 2. It does not equal to 0. False. It's not a factor. If you actually look at this previous example, you may have caught it already, but this is also another factor. So right now, you can actually try doing the same steps for C, and it should also be a factor. So if you already caught it already, like, whoa, Miss So, I noticed that C worked as well. That is true. For this example, I made it so that we have 2 possible answers. So you can actually try to use the factor theorem for choice C.